and welcome to the Actual Astronomy Podcast, episode number 15. In this podcast, we're going to take Shane on a tour of the terrestrial planets. So buckle up.
Yeah, can't wait.
Good stuff. So it's May. It's mid-May now. Getting into the second part of May, I suppose. Now we're just past the midpoint when we're recording this. And I should be in the middle of teaching my spring astronomy non-credit class at the university that I've been teaching at for the past almost decade now. And you should probably have a couple of fishing trips under your belt now.
Yes.
So life definitely is not the usual role. But anyway, so my course, which you've attended and guest lectured at on many occasions, is meant to be a practical astronomy course, and by that I mean that this course that I facilitate is meant to provide information on astronomy, but really to give people the tools and knowledge to actually go out under the night sky themselves and begin identifying stars, planets, constellations, how to see the Milky Way from reasonably dark sight. And some of my students, not that they're my students, but really, I kind of create the class in partnership with the students. They eventually begin working towards like observing nebulae and galaxies and clusters using binoculars, and then even a small number will graduate to looking through the telescopes. But yeah, it's been a lot of fun, and I know you've been to the class and enjoyed it.
Yeah, I always enjoy talking at your class. The people are interested in all sorts of astronomical topics, and I enjoy talking about that stuff. So it's a match made in heaven.
Yeah, it's pretty cool. And the sort of the one thing is that many classes, especially at the university level, and this is not a university level class, it's a non-credit course that I do through the outreach division, and I'm a volunteer facilitator, but it's more organized than what you would get at an astronomy club. And that was one thing I always thought was I don't want to say lacking, it's just difficult to deliver consistent content like that through a club.
Yeah, it is. And I like the freedom of your class. Like, there's no real constraints. It's just go talk about astronomy.
Yeah, and see what people are interested in, and then attempt to deliver that in a 4 to 8 week format. So and then hopefully we get some clear skies, and I take people out, and yeah, I've had like 300 or 400 people through the course now, like just over the past 8 or 9 years, into the 9th year here now. So yeah, it's a lot of fun. So we are basing this podcast because our original plan was to do some astronomy last night and then do a podcast on that in our fatigued state. But unfortunately, we're both wide-eyed and bushy-tailed, and the astronomy gods were not smiling upon us, unfortunately. So yeah.
Yes, the weather did not work out for us, but keep our fingers crossed for the coming days and weeks.
Yeah, and today was supposed to be sort of the end of my vacation. You say you were just starting to take vacation. This was going to be sort of the tail end of my vacation. I was going to take the past week and a half off, and we're going to go on a trip. I was going to go to the Jasper Dark Sky Preserve and do some observing up there, and some other things. And my wife had a conference on, but of course, all that was trashed due to the COVID-19 business, unfortunately.
Yeah. Was this the weekend we were going to be in Grasslands, or is that next weekend?
Yeah, so I can't remember. It was either this weekend or next week. I think it was actually next weekend that we were supposed to, yeah, because this is the first weekend where they should have been open. They're not open. And it is always a bit of a challenge to kind of host us. And, originally when it was only like me and you and Mike and 5 or 6 other people, and then we get a few people from the local area come down. It was fun. When we had less than, a couple dozen people there, they could just kind of throw the doors open and do what you're going to do. It's no problem. But then I think in the past couple of years, we've had like 300 people showing up to our event. They're like, that's like, we got brand new park staff on. We're trying to train them. And now you guys are wandering in here with a couple or few hundred people. It's really like difficult. So I think we're a little bit of the victims of our own success there. So, but it's great. It's great that so many people want to come down and join us, and it just means that we have to move typically a weekend ahead or around to make sure that the park are able to come in and and able to do that. Like I know last year we went down, Shane and Rick and I, and we did some training with the park, kind of as a lead up to that, but it didn't make it any easier. So,
Right.
So yeah, it's just unfortunate, but they get their new staff in, they can train them up. But unfortunately, this year, none of that stuff is happening, anyways, as far as doing park programming. And I have heard officially from the park and have been in conversations with them, and yeah, 100%, we are not going down there to do park programming this summer. So that's so yeah. But this presentation, or it's not a presentation now. I've kind of broken it out as a bit of a tour of the 4 rocky terrestrial planets. So the sun rules the solar system, and then going out from the sun, we have these 4 rocky worlds, followed by 4 gaseous planets, and then those are separated by what is sort of incorrectly termed the asteroid belt, because it sort of creates a vision in people's minds that is not really based on reality. So Shane, maybe we'll start here. And I always love to throw this at you, because you actually, when I do these ones that are semi-scripted, you actually don't get to see the script first, and I like that.
I think you get a strange, I don't know, satisfaction out of that, actually.
So that I feel like I can really put you on the side. You haven't got anything wrong yet, except for I think I asked you what your favorite telescope was once, and you couldn't figure that out. But can you name all the planets?
Well, yeah, I think so. Now, by what definition are we talking about here?
Just
minor planets, major planets? I don't even know.
The 8 planets that the IAU is now going with. Yeah.
All right, I'll even do them. What I think is even the correct order here.
Here you go.
So we go Mercury, Venus, the place we live, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
There you go. Perfect. Yeah, that's awesome. So we also have what are called the inferior and superior planets. Now, I don't want to put you too much on the spot, but do you want to give a bit of a definition for the inferior and superior planets? Are you good with that, or should I just?
So inferior, that's like Pluto class?
The inferior, well, no, it's not, because they're little planets. No, the inferior ones are on the inside of the orbit of the Earth, and then the superior ones are other ones that are on the outside. But I know it's like one of those things, and one of the real one of the real benefits that I get out of teaching these classes is that all these kind of semantics and language, I end up having to kind of rebone up on and really learn, because when you're explaining it in front of a group of 20 or 30 people, you really want to make sure you have those definitions right at the tip of your tongue. So one of the things that newcomers should understand is that you can actually see 6 out of the 8 planets without a telescope or even binoculars.
Just your naked eye. That's all you need.
It's like, that's one of the things that I think that people find most surprising.
Yeah.
And that it's only distant Uranus and Neptune that just require a decent pair of binoculars. And really, the thing you need is a good pair of like an 8 or 10 by whatever binocular, but is a good little chart. Usually like Sky and Telescope, the Observer's Handbook, you can just Google it online and find a good chart to locate them. And they're also on, I think even skymaps.com puts them on their printouts, but you're going to want to have a little bit more detail than what those show. But to see any real detail in any of the planets, you need telescopic powers for that. Hey, is that a fair?
For sure you do. And maybe just a qualifier, like Uranus and Neptune, even with a telescope, there's not a lot to see there. Maybe a little bit of color in Uranus because it is a blue planet, but you're not really going to see surface details unless you have like a major telescope of huge aperture.
Yeah, I mean, I've looked at them through like decent 10-inch scopes, and And even with that, haven't really been able to see too much. And so I was talking to my friend Dave the other day. He's the former editor for the RAC Observer's Handbook, and he had listened to our Venus podcast. And so he mentioned that he was on vacation. It must not have been recently. It probably was last year's, his last winter vacation. And he was saying how, no, it wouldn't have been last year. Anyway, it was 8 years ago. Anyway, I won't get into all that. But he was down south somewhere. This was just before the transit of Venus. And there were some people doing like selfies and this kind of stuff in front of this, what they were saying was this bright star on like a cruise or something he was on. And then he said, hey, well, that's actually not a star, that's Venus. And then they kind of like looked at him, they're like, how do you know this kind of thing, right? Oh, well, I'm an amateur astronomer. And, that's sort of what we know. But I always find it kind of a neat party trick. So, I mean, like, I'm really into astronomy and, my friends know this more now, but when I was much younger, it's not like something I necessarily went out and advertised so much. I kind of just did it for fun. I did it at night as sort of my own sort of personal thing and didn't really belong to clubs or anything. I had my telescopes and my star charts and lots of books and go online and read lots of stuff, but it was like my own little thing and never really bothered too much. I used to take my cousin Will, who does our music, out with me, and the odd friend, but other than that, I didn't really, like, my friends just weren't into it, so I never really talked that much about it. And every once in a while we'd be out like on a balcony or something, like eating dinner or whatever, and someone would look up and say, hey, that's funny, that star wasn't there like last week. And it's, oh, well, that's Venus. And then they kind of look at me, and then I'd say something like, and that's Mars and Jupiter, and then that star over there is Vega. And then I kind of like give them a bit of a sky tour, like, just, well, they're not even taking it in because they're so bewildered that this person sitting in front of them like knows what all the stars are, and they're just like, what is going on? Like, how do you know all this? So, and then I'd always just sort of pretend like, oh, well, don't you know this? Like, everybody knows.
Just a jerk.
And then just kind of go back to eating dinner and, what are we doing next kind of thing. So,
but it is something that when you, as amateur astronomers, you pay attention to where the planets are during the various seasons. And once you know that Saturn is about to become visible, it really, it's not that hard. You'll quickly learn the positions of the planets
right,
relative to the season. The bright stars are always pretty easy to pinpoint in the sky, and it just comes with experience. And it's really not that big of a feat once you get into it.
And one of the other tricks is to is to take note, like, kind of once you get used to where the planets are on that, is that the stars will twinkle, but the planets, because they're extended objects and you have multiple streams of photons coming at you, they tend to average out. So the planets won't really pulse or twinkle that much. And if you get really, really bad seeing, like the other night, I think I could actually see kind of Venus even twinkling a little bit, but like on a typical night, and even still, it really wasn't really twinkling. On a typical night, planets they'll remain a pretty solid, very bright star-like object. And of course, as soon as you put binoculars or anything on it, you can actually see that it's a little round thing or close to round. And then any kind of telescope will really give you some detailed view. So let's begin at Earth. All right. So we're here anyway, and whatever. And Earth is helpful because we use it as a metric, since we're all at least somewhat familiar with its size, and familiar that the sun is in the sky, but it's really far away, and that we have the moon in the sky, but it's also closer than the sun, but still far away enough that takes astronauts, when they did go there, which is, I think, before our lifetimes, it takes them a few days to get there. But the sun is about 150,000 kilometers away, or 93 million miles from Earth. And we call this distance, and this is sort of like one of those key things, this is should I put you on the spot? What is the Earth-Sun distance called, Shane? Can you do it off the top of your head?
1 astronomical unit.
Yeah, I feel like this should almost be like our game show. So bing, so. Definitely got that one. That is a critical number that everybody should know. And then, because these numbers are so big, like, it's hard for me to really conceptualize of a 150 I think it's like 150 million thousand kilometers. Anyway, these are really huge numbers. And the moon is 384,000 kilometers away, right? So
Hmm.
the moon distance is more easy to get our heads around. So if I kind of get whatever, if I said the sun is so many miles or kilometers from the Earth here, really what we're talking about is an astronomical unit. It's so far that it takes light 8 minutes to traverse the space from the sun to the Earth. That's how far away it is. The moon is much closer, but it still takes like around 8 seconds or so, I think, or something like that. That takes a few seconds for the light to go. And it's 384,000 kilometers, which was approximately the distance that I had on my Celica when I traded it in a few years ago. Let's see, that's about 30 Earths, right? So depending on whether or not we have a supermoon or not. But due to a coincidence, the moon is about 400 times smaller than the sun, but the sun is about 400 times farther away, meaning that they appear to be approximately the same size in the sky as we see from Earth. So why is that important, Shane?
Well, that enables a total solar eclipse, but also for anybody that's seen a total solar eclipse, some really amazing effects because the sizes almost match exactly. When the moon masks the sun, you're able to see like some very beautiful light arches and prominences off the surface of the sun through binoculars or even really just using your naked eye. It's an incredible experience and something we're kind of fortunate to be able to experience because of this phenomena, because the moon is kind of moving further and further away from Earth every year. And I forget what time frame it is, but there will be a point in time where the 400 and 400 you just talked about no longer is accurate because the moon will be further away and then it won't look as big as the sun in the sky, and total solar eclipses will be a thing of the past.
So I'm going to just say, because we can never stress this enough, that you're never going to never look at the sun. You can go blind instantly, or at the very least have very severe, permanent, long-lasting damage to your vision. And so we are experienced amateur astronomers. Even still, we take great precautions. And even still, I know people that have eye damage from accidentally even looking at the sun, even attempting to take all the precautions necessary. So I'm really someone that doesn't really observe the sun at all. As you know, like I'm pretty paranoid about it. I know that you've got some pretty specialized equipment for looking at the sun. And really, anybody listening to this is not what you start doing when you get into astronomy. You want to find people who are experts in this, and you want to take every precaution necessary before you look at the sun. You want to find somebody like Shane, and he can kind of guide you through it. And we've certainly showed lots of people the sun through our telescopes. But boy, when we do it, we are set up just the right way to do this very safely. And we have, very specific instructions, and we're able to stand there and monitor and guide people on how to do it exactly in a way that is very safe to do. Like you have to be very careful doing this.
You do, and you don't want to mess around. And even I almost blinded myself one time because I do have some very specialized gear for observing the sun. And one piece of gear I used to have was a filter that you could put on the front of just a normal telescope. And this filter would take about 99.999% of the light away from the sun. So that's dim enough to observe it safely. Um, so I'm getting set up to observe the sun. I drop my eyepiece in and I was about to put my eye up to it when I just sensed this heat coming from it.
Yeah.
And I had forgot to put my filter on the front of the telescope.
Yeah.
Completely brain dead at the time
Yeah.
and nearly lost my eyesight.
Yeah.
Had I, made my way to the eyepiece, it would have been instant.
Yeah. So you have to be so careful. And yeah, it's just one of those things. You really want to make sure you're being super, super careful. I like those telescopes that are only the solar viewing telescopes. I have one of those borrowed from the Astronomy Club for a while, and those are great. And I had somebody who really wanted to look at the sun, and I was able to kind of say, hey, this is the thing. And I got them to join the club, and then they were able to kind of borrow that for an extended period because that's really what they wanted to do. But I'm like, had to train them up, show them how to do it safely, how to use these kind of filters properly, and then they're good to go. But that's kind of what people should do if they do want to take a look at the sun. Go find an astronomy club, get trained up, learn how to do it safely. It's not worth looking at. Losing your vision. You lose your vision, you're not going to look at anything else anymore. So it doesn't make any sense. So the Earth has a diameter. I'm going to talk about some numbers just so people kind of get a concept. I'm going to kind of use the Earth and the Moon as our scale. But the Earth has a diameter of just under 13,000 kilometers, just under 8,000 miles, and it's just over 40,000 kilometers, 24,000 miles around the equator. The Moon has a diameter of just over 2,000 miles, about 3,500 kilometers, and is almost 6,800 miles or 1,100 kilometers around the equator. Now, those are the only numbers I'm going to throw to you, so kind of latch onto those. But I'm really just going to say stuff is this many Earths or that many moons or whatever. I'm not going to get into the miles and kilometers and everything else. So, and what you want to do is you also want to recall that your fist at arm's length is about 10 degrees on the sky. So, how big? Here's another question for you, Shane. And I'll give you some options here. I'm gonna roll this out. So, if your fist at arm's length is about 10 degrees, all right,
Mm-hmm.
what sort of object would you have to match to equate to the size of the moon, or to cover the moon? Would it be A, an inflatable beach ball?
No.
Would it be B, or would it be B, a volleyball?
Negative.
Or would it be C, the end of an eraser on a pencil?
Yeah. Or a finger, I think, right? Isn't a finger about 1 degree?
Yeah, so it's really about the size of the end of the eraser. Like if you held your pencil like lengthwise, I think that is about the size, or about the size of like a Tylenol or something like that. So it's pretty small. Like it's surprising. So, and this is one of those other things where I'm at work one day and people were talking about the moon. The moon was rising or setting in the morning sky, and it was just past full. It was like a harvest moon or something in the fall a few years ago. And someone said, "Wow, did you see the moon this morning?" And I'm like, "Yeah, but it's really not that big." And they were like, "What are you talking about, Beckett? This is the big moon in the sky. Like, have you not see this?" And I went, "Well, it's about the size of this eraser on the end of my pencil." And they said, "No, it's not. Like, you don't know what you're talking about." I said, "Let's go and look." So I took the pencil out, I held it up, and these people were kind of freaked out that like that's what it was, like that was the kind of size, right? Just to kind of demonstrate that. Again, they didn't really know I was that into astronomy, and I kind of had this sort of scale, and I'd done this before, so I knew it would work. And one person actually fell over. Like when I did this, they were so like it was icy in that, but it was like something that really kind of tripped them up. They were so surprised that I could actually demonstrate this. So now earlier we talked about what is a planet. Now, according to the International Astronomical Unit, the planets have been defined as these 8 that we went over earlier: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, as objects that have basically cleared out the general vicinity of their path around the sun and the solar system. There's a lot of debate over whether it should be that or something else, and we're not going to get really into that here, because whether it's classified as one thing or another, to us in many ways it doesn't really matter. They're just as interesting or not interesting as they were prior to this classification or reclassification, which I think they came up with about 15 or 20 years ago now. But the first 2 planets we're going to visit, they're going to be Mercury and Venus. And these are really bright. And you only see them in the morning eastern sky or the western evening skies. Those are the only places that you ever see Mercury and Venus. And they are inferior planets. And this means that they are on the inside of Earth's orbit. And because of this, you never see them in the sky all night. But as a bit of a consolation prize, they have one really neat trick, Shane, that is unique to these 2 planets that the other planets don't have. And what is that unique trick?
They transit across the sun. So
that wasn't what I was going, but that is
oh,
one neat trick.
yeah.
Very good.
So just a transit is from our perspective on Earth when you can watch Venus or Mercury cross the surface of the sun. And that's actually Mercury, not quite as rare, but Venus, it happens like twice every 111 years or something like that.
Yeah. So what I was actually going for, and that's a good point. I had this further down, but is that they show us crescents
Ah, yeah, yeah.
because of their inferior nature. But you are absolutely right. Yes, they are also the only two that do that. So we'll see. We'll give you the point. We'll give you the point.
Okay, okay, yeah. I
So
deserve it.
you deserve it. You definitely deserve it. So, and I was going to say you definitely observe it because we actually have observed these transits. Again, this is solar observing, and all the precautions I spoke of earlier go for observing transits with the sun, as well as just regular solar observing. So don't do it unless you know what you're doing, or go seek out people who do, and they can show you how to do it safely, or show it to you without you having to really do anything at all. So when Mariner 10 flew past almost 50 years ago now, it revealed a gray cratered world that was Mercury. And it's small, it never rises high in the sky, and it basically looks like the moon. So it's often been said, I don't know whether this is a legend or whether it's true or what, but that the author of the heliocentric theory, Nicholas Copernicus, it said that he never observed the planet Mercury. He was never actually able to see it, which I can kind of understand. So I'm not from the prairies. In the prairies, you'd say, man, how could somebody miss that? Because you've probably seen Mercury quite a few times, Shane, eh? Like here.
Yeah, yeah. You have to be looking for it and know
Yeah.
where, but because of the flat prairie, it's easy. If you want to see it, you can.
Flat prairie, good horizons, really clear sky here. Like the sky here, I've seen stars down to the horizon naked eye, like a reasonably bright star. I've watched them set. Like I watched a star set one night, and the next day, like I was out at the parks and I was doing some work for the parks for astronomy, and then I stayed on a couple more nights. And they said, "What did you do last night?" I said, "It was really clear." "What'd you look at?" I said, "I watched a star set," and they were just like, "No, really? What did you?" I'm like, "No, like if you think about this, this is like something that you never get to do." Like I picked a reasonably bright star. I think it was Arcturus, and I actually watched it set behind a hill. Now the hill kind of came up a bit, so it blotted out maybe a few degrees of the horizon, but like less than 5 degrees, less than 10 degrees, and I could see it actually go down. And I might have lost it maybe the last, you know, degree or so, but it's really strange to think of it. You don't often think about seeing the stars right to the horizon as being a rare thing, but that is definitely a rare thing, and you can do that out here. So the reason why Copernicus probably would never have seen it is he lived in a maritime environment, which is like where I'm from, and to see Mercury there is a little bit more challenging. So that's just sort of the nature of it. I won't get into too much more about that. But Mercury is very close to the sun. And again, like you have to be very careful trying to observe Mercury. You do it after the sun goes down. And Mercury has an orbit of just 88 Earth days, which combine with the 59 Earth day length it takes for it to actually rotate on its axis. So that means that it takes about 176 Earth days for the sun to rise and for the sun to set on Mercury. So it's kind of like a strange thing where the orbit and the length of the rotation sort of factor up to give you this sort of longer day than sort of either the orbit and the rotation combined would allow. So sort of a funny way to think about these planets. So this means that during our year, Mercury will go through a variety of cycles, and we'll have a few opportunities to actually see it go into conjunction. We might get a transit of Mercury, and we can best view it when it's at greatest elongation. And that means when it's coming up pretty high, either in the morning or into the evening sky. And what does it look like to you, Shane, when you've seen it?
Venus
Mercury.
Mercury. I've never actually put a telescope on it. I've just naked eyed it.
Oh, really? Oh,
Yeah,
cool.
yeah.
So I've done some observing of Mercury, and to me, it just kind of looks orangish. I think because it's very small and it's bright and it's in our atmosphere very low.
Yeah. The horizon taking over a little bit.
Kind of like, when we have a lot of maybe haze or whatever, and the moon is rising or setting, and it kind of takes on that orange glow. It's kind of like that, but I think it's because it's it's just so small. Um, you get that sort of more of a pinpoint effect. So to me, it seems very orangish. But Mercury is very small. It's not much larger than our moon, and it's smaller than Jupiter's moon Ganymede and Saturn's moon Titan, and only like 1,000 miles larger than Earth's moon. And like it's getting smaller with every year because according to the NASA Mercury Messenger mission, they discovered that there's these Mercury quakes that take place, similar to an earthquake, but on Mercury, they would be Mercury quakes because the planet's tectonic activity is still taking place and it's shrinking down a little bit. So
Interesting.
yeah. One of the interesting things, one of the other interesting things is even though it's really close to the sun and gets very hot there, there might still be some ice in its north polar regions because of comets and that have crashed into it in the past. And some of those big craters in there are in perpetual darkness and are able to keep the temperature down because there's no atmosphere on Mercury to kind of move any of the warmth around. You're just sort of starkly out in space. So either you're in the sun or you're not in the sun. If you're in the sun, it's hot. If you're not in the sun, it's cold. And those are perpetually in the cold. And also the South Pole may contain some icy pockets as well, but they were less able to see those. So I've seen some sketches and images people have done of Mercury, subtle at best to see anything on it. So
would you need big aperture or just high kind of contrast aperture?
Yeah, high contrast, good seeing. Yeah, I've seen all kinds of weird and wonderful setups to try to see this. Setting up during the day and waiting for the sun to go past, and then taking a look once it's safe to do so. But yeah, it's a bit of a challenge. So that's it for Mercury. So Venus is our next object that we're going to chat about. We've talked a lot about Venus quite a bit. Venus has a 225-day orbit on Earth day orbits, and or Earth days. It has a 225-day orbit, and it's only about 100 times farther away from us than the moon. And we're actually approaching that time now where it is so close to us. We're getting that beautiful crescent, eh?
Yeah. And getting thinner every night.
Yeah, exactly. It takes 243 Earth days for Venus to rotate on its axis, which is 18 days longer than its orbit around the sun. And that means that the length of its day from sunrise to sunset is about 117 Earth days. So get your head around this. It also rotates backwards. So if you could actually stand on its surface without being crushed to death, you would notice that the sun rises in the west and sets in the east, and then you would probably be crushed to death. So Venus is often said to be Earth's twin gone awry because of its runaway greenhouse effect. As a result, the temperature on Venus reaches a balmy 880 degrees Fahrenheit or 471 degrees Celsius. And in 1970, the Soviet Union's Venera 7 was the first spacecraft to land on there, take a photo, and then it was crushed to death. If it had survived a little bit longer, it would have noticed that there's a lot of volcanoes spewing out all sorts of nastiness, including things like sulfuric acid rain that's falling from the sky. That's a very unpleasant place to try to exist. From 2005 to 2014, the European Space Agency's Venus Express spacecraft found evidence of lightning on the planet, which forms in these sulfuric acid clouds, unlike Earth's water clouds, but like them, also has lightning. There is a long-lived cyclonic storm on Venus that was first observed in 2006, and it appears to well up from a variety of elements that are breaking down and breaking apart in the atmosphere. And currently, there is a spacecraft. I should see, I'm not going to quiz you on this because I had no idea there was a spacecraft still in orbit around it called, and it's a Japanese spacecraft. I'm probably going to get this wrong, called Akatsuki. And it remains in orbit, but it had a very troubling start in 2010. And some of its cameras never worked. And it's basically just observing the climate and measuring the lightning and air glow around the planet. So had you ever heard of that Japanese spacecraft before?
Ooh, I don't think so. Yeah, it doesn't stand out.
Vague at best. And I think, yeah, like when I
Yeah.
looked, I was like, oh, there's one. And then, yeah, its engines didn't work and it had trouble in the launch. And then it took longer to get there. And then when it got there, a couple of cameras stopped working. But it's been able to do a bit of a hampered mission, but carrying forward. And it's been extended into the end of this year. So maybe once it's finished, we'll, get some better stuff. So let's see. Venus is now getting to be a very razor thin crescent. It's very bright. It's at what, magnitude -4 right now?
Yeah, extremely bright. Still, it's incredible how bright it is, despite how much light is actually being reflected back to us.
So I was thinking one thing we should do, maybe we can do this next week or one of the other weeks we have coming up, is the magnitude scale.
Yeah.
And actually explain this properly to people. And when we're referring to how bright and faint things are, we can say magnitude, and then people know what we're talking about instead of just throwing these numbers out. But there's a lot to explain with astronomy and visual astronomy in particular. So it takes a while, and that's, I think, one of the benefits of doing these podcasts. But regarding Venus, one last hurrah this month from the 18th. So that's tomorrow for us. So hopefully you'll be able to get these up sooner. From the 18th to the 24th, Mercury will appear to overtake Venus in the evening sky, and the best views are likely centered around 1 hour after sunset local time. So if you go out, and in particular on May 23rd, so I know, Shane, you put these up and they're staggered. If you can put up the one we just did, and then a few days later put this one up, but before the 23rd, on the 23rd, people can use their binoculars to scan directly below Mercury and see a very, very thin crescent moon. If you have a telescope, you'd be able to see the crescent Venus, the crescent Mercury, and the crescent moon, kind of by panning around and sort of going back and forth in the sky. So that May 23rd date, that is the one to mark in calendars. And we did talk about it when we did the things to observe in the night sky for May 2020. So
Right. Yeah, I'm looking forward to that. Although, again, weather forecast, we have to keep our fingers crossed, you and I, because I think Monday, Tuesday are the only good nights so far this week by the looks of things.
Yeah,
more to come.
Things change. And the other thing I heard is the weather forecasting isn't what it used to be, because they used to use a lot of the atmospheric readings from airplanes to actually create the weather forecasts. And that I heard today that Air Canada is only flying 5% of what they did a year ago. So definitely, when each plane that's going up and down our atmosphere over, our country, over all countries, collecting a little bit of data on each of those, now no longer having that, they're saying that our forecast is likely to be impacted enough that we would notice that. And it has been, like, some days it's like, I didn't think it was supposed to be windy today. Where did this wind come from? And today it's very windy. There was no wind in the forecast when we went to bed. Now it's blowing a gale out there at like 50 kilometers an hour. So. All right, last planet that we're going to do today, and I think what we'll do is we're just going to do the terrestrial planets, these rocky worlds that are in close to the sun. Mercury, Venus, Earth, and Mars. These are the rocky planets. And then next time, when we sort of come back around to one of these, we'll do the gas giants. All right. So we still have Mars, and there's been a lot of chatter about going to Mars. Shane, would you go to Mars or not?
Yes, sign me up. I'd go.
You would.
Oh yeah.
Good.
I think it's awesome. The whole concept of like pioneering and exploration is near and dear to my heart, and yeah, I think it's pretty cool. Yeah,
I would not go.
It's a death sentence. You're not coming back. That's for sure.
I would not go to Mars. It's it looks great. The brochure looks wonderful, right? It's kind of like that condo sales pitch that you went on that time you told me. But anyway, it's only about twice the size of our moon, and it's barely half the size of the Earth. You need a spacesuit to go walking around. I think that because often they're saying in our weather forecast that Saskatchewan is colder than Mars, that you have a false sense of security going there. But let me tell you, my friend, this is no pleasant place to go. But one of the advantages.
But imagine how dark the night skies would be without light pollution.
That's right. Now, one thing that I like is if I went there, the one thing that could convince me to go is that the day on Mars is 24 hours and 37 minutes. Now, if you told me that I could just sleep in an extra 37 minutes every day because we're staying in Earth time, that might sway me. That'd be pretty nice, pretty sweet. So the orbit is 687 days, and it's about 2 astronomical units from the sun. So about twice the distance from the sun as the Earth. But it's about 1 astronomical unit from the Earth most of the time. And it gets just close enough for us to get this really hazy, foggy view of Mars to draw some perhaps all too close similarities to Earth. But it's really still too far away to draw any conclusions from our planet. And this has led to much speculation because the eye and the brain and the mind, they all work together in such a way to make these really vague things look like little streaky bits. And then there was a guy named Schiaparelli about 150 years ago, not coincidentally, right before he actually completely lost his vision, he named them canali, which is Italian for channel, at least according to what I've read. I don't speak Italian, but I've been to Italy, and these have been misinterpreted to mean that little green men were, and I suppose little green people maybe, perhaps not just the men, were digging ditches for water to irrigate their fields. Typically, they refer to those as little green men, and I don't think so. And once they got there, no, that wasn't happening either. So we've had several landers now, and there's been 3 sizable rovers that are patrolling the surface, and they haven't run into any creatures at all
that we know of.
That we know of. No little green men, as they call them. So they found some old stream beds. But there's a really close connection between this exploration of Mars and where we live in Canada, if you recall. So because when I was the president of the Astronomy Club, I got this email from a guy named Jack Mullard, and he was with the Geological Society of Canada, or whatever it was, Saskatchewan. And he wanted to bring a NASA scientist up because it turned out, and he was a person of some age, that he had actually trained the NASA scientist on how to pick good landing spots to put down on Mars. Because Jack was the first person in the world ever to use aerial photography to interpret and figure out land formations and mineral deposits for, I think, mining and some other purposes. I didn't really get into all that, but he definitely, that's what the guy did for a living. And so when they were first sending on spacecraft on Mars, he was flown down to NASA and did all the training, and it was really cool. So I was able to go out for lunch with him. He was able to kind of walk us through that. And then when the guy came up from NASA, we had Jim Rice up, and you could see they really knew each other, and had worked together on that project so many years ago. So yeah, it was kind of neat, eh? Like, I think you remember that as well when we went through that.
Yeah, it was very cool. Very neat to see the approaches that they used and the analysis. It's very fascinating.
Yeah. Now, I've been observing Mars this is the thing that I've observed the longest out of everything in the night sky. So
me as well. When I got my first real telescope, that was the Mars year of the closest approach
in 2003.
Human history. Yeah.
Yeah.
And, unfortunately, I didn't have the experience that I have now to really appreciate it, but it was incredible back then.
Well, I'll tell a funny story. So when I say it was the first, I mean going way back. It was the first thing I ever identified the nighttime sky, because when I was really little, I had a goldfish, and that goldfish died. And I was really upset. And it was sort of one of those orangey goldfish. And my sister, seeing how upset I was, she told me that the goldfish had been cast into the heavens, and that orange star up there, that was the goldfish. And I can't tell you how much better I felt. So wow. I was pretty little. And so when we were kind of going off to church that Sunday, I kind of had mentioned in the car to my folks that, I had perhaps planned to announce this to the congregation that Sunday. And it was all they could do to stop me. So that would not have been the first time that I had made a public announcement in church without my parents' knowledge. They kind of give me the one up to please let them know in the future if I was gonna do that. So it was really cute when I was little, became less cute as I aged. they kind of talked me down off that. And then it was like really soon after. My mom, she's sort of a person with a bit of a science background, and she started, and she knows a little bit of astronomy, and kind of was the one that really sort of sparked this in me as a kid. And she started cutting out these newspaper articles by Terrence Dickinson for me to read. And so she very quickly guided me to some resources that helped me to identify that this was not my goldfish in the sky, but it was the planet Mars. So that was I think probably the very first thing that I ever identified up there. But then eventually when I got my telescope, now I got my telescope an opposition or two, probably about two, maybe even three oppositions before that big one in 2003. And I knew I knew that the 2003 one was coming up, and I wanted to get a couple oppositions under my belt in order to do that. It was like one of these big events that was sort of being promoted. And then I got my 8-inch Dobsonian. I put it out at my driveway, and I looked at Mars. That was the very first thing I ever looked through a telescope that I owned anyway. I think I looked at the moon and maybe some other stuff before, but I was able to make out Syrtis Major, which is this sort of African continent shaped plateau. It's probably about the easiest feature to see. But what have you observed of Mars, Shane? What have you been able to make out there?
Well, the polar caps, those are usually fairly distinct, and you can pull those in. And then I'd have to refer to some of my observing notes actually, but in a few of the major surface features, I can't think of it all offhand right now. Mars is being sort of fleeting, and the last opposition, while it was favorable, there was a giant dust storm, so it washed out a lot of the detail, and it just was an orange globe that you would see in a telescope without any of those features. So kind of disappointing last time, but
Yeah.
Fingers crossed for this one.
Yeah, hopefully. Yeah, the last time I think I looked at it maybe 2 or 3 times, and there was really not much to be seen there. I kind of figured there would be a dust storm that time. I didn't even ramp up for it. This time, I don't think there'll be a dust storm. I've kind of done a lot of research on that. They have fairly good ways to predict when there'll be dust storms, and not, it seems. So I don't think there's going to be one this time. So we'll see who's right and who's wrong on this one. But eventually I go on to see polar caps. I've seen deserts. And then one night, and this was sort of good and bad. So I had my astronomy class out, and this was I think it was the 2016 opposition. So the 2016, I think there was one in 2013 or 2014. Anyway, I had my astronomy class out, and I told them this was happening, and that the next week we were having really good weather, and where we live, for having good weather, we tend to keep it for a little while. For having bad weather, we tend to keep it for too long. And so I said, I'm going to bring the telescope, and I don't remember if you came to that session or not, but it was really good. It was the best seeing conditions that I'd ever experienced. And people from the class, they step up and they look in, and nobody had trouble seeing the details. It was ridiculous. We could see the polar caps. We could see detail on the surface. We could even see clouds kind of, hovering over Amazonas, in the area where, the giant volcanoes are on Mars. You couldn't see the volcanoes, but you could see these clouds and that. And this one person, they were there, and they just looked and looked. And kind of told them all this stuff. And I said, this is it. This is like as good as it gets. And I probably shouldn't have said this, because a couple of people never came back when I kind of said, this is as good as it gets. And I think they were like, this is as good as it gets. Oh, we're out of here. Like, that was it. They never came back, which is fun. But yeah, you can always get those rare evenings that are so good. I've kind of had a couple of those. I should have learned my lesson the first time. I had this person who wanted to go observing, and they actually lived about an hour away from this really, really dark place. And so it was east of where I lived and north of where they lived. And I said, I'll meet you there. And I kind of gave them the coordinates, and we showed up, and it was really good. It was the best night that I ever saw to that point. And I told them this. I said, this is the best night. This is it. I said, this is really good. Definitely the best night I've ever had doing astronomy in, at that time, 15 or 20 years or whatever it was. And they were really disappointed. You're like, like, well, I still can't find this stuff. And, gee, this is the best. I'm like, yeah, this is it. This is, this is as good as it gets. It doesn't get any better. Like you hope for these nights. And then, yeah, that person, they also, very soon after kind of put it in. So I should have learned my lesson. We should learn our lesson from those things. But anyway, so that's pretty much it for Mars. Mars has 2 moons, and you won't really see them. They are too small. They're kind of like giant potatoes and are very likely captured asteroids. If you want to read more on Mars, the book that I'm reading right now, it's a book you can usually pick up in a discount bin once the bookstores are back open, or you can buy it used online for about $3 Canadian. I paid $2.95 for my copy of Patrick Moore on Mars. And then also a really great book that you can't buy anymore. It's long out of print, but it's freely available from many, many sources online, is Antoniades, The Planet Mars, as translated by Patrick Moore, is another great text. So that's our little tour of the terrestrial planets, our 4 terrestrial planets. What do you think, Shane?
Which one is your favorite to observe through a telescope?
Through a telescope, it's hard. Yeah, probably Mars. I've observed Mars a lot, and you can kind of see these features. Though I've really enjoyed the recent sessions on Venus. Those opportunities are sort of few and far between when it is in the correct phase. So, how about you? What's your favorite terrestrial planet?
Well, similarly, like Mars has been the key one, just because there's a lot of detail that you can try to tease out of it, and it can be a challenging target just because of its distance and size. Like it's small and it's a long ways away. So in order to get any kind of detail coming through, you really have to spend some time at the eyepiece and hope for good seeing conditions. However, these recent Venus observations really have me intrigued and actually excited for the next Venus observing season when we can see like half of the disk and try to pull out some detail there. So, it's a little bit of a toss up. I really enjoy looking at both of them. I'm also excited to talk a little bit about the gaseous planets because, we spend a lot of time looking at those too.
Yeah, it's just in doing this now and kind of thinking about, I'm like, oh, we should have said this. Like we should have said, you never get to see surface detail on Venus. You're only ever going to see the clouds, and you're really lucky to make out some detail on the clouds of Venus. And as well, just because the orbital eccentricities, we really only get these really nice opportunities with Venus so well placed like this every 8 years. Like it's just kind of unfortunate, and the cycle will repeat. Now we'll get some other opportunities, but like these ones where it just kind of seemingly hangs in the evening sky for months and months and months, and you have ample opportunity to get out. They don't come along. You'll get it again, and then it won't be that high. And it depends on how much morning observing you wish to do. I like to do a little bit more morning observing, I think, than you do. So
yeah.
That is one. Okay, well, if anything else you wish to add, Shane?
I have nothing at this time, sir.
Okay.